All right, here's where 7.4 begins. The part A is still 7.3. Part A is still simple interest, but part B is compound interest. So right here is where 7.4 kind of starts off. So when we do the part A part, the simple interest, we want to know how much interest there would be if we invested $100,000. So that's our P at 8%, so that's our R, and 6 years, so that's our T. So we can just, simple interest is easy to find because you just use that I equals PRT formula. Compound interest is a little tougher. So it turns out to be $48,000. When you do try to figure out the compound interest, there is not a formula where you can directly get the interest. So what you do is you find out what the future value of the loan would be by using the compound interest formula that looks like this. And it'll be on the formula sheet. So you're going to plug in the 100,000. You're going to take that interest rate of 8% and divide it by how many times the interest is being calculated in 1 year, and since it's once per year, n is 1, and then you're going to put 1 in for the n up here also, and then 6. So I'm going to type in 1,000. 1 plus 0.08 over 1 is just 1.08, and I'm going to raise it to the 6th power. All right, so when I do that, that's 100,000, so don't have a typo with too few zeros like I did. All right, so let me type that in. I'm going to do 100,000. I'm multiplying it by 1.08, but that 1.08 is raised to the 6th power. Okay. All right. All right, what I wind up with isn't the interest, it's the future value of that loan if they did that compound interest. We typically will be rounding to 2 decimal places because that's rounding to the nearest cent, and then that's the future value, so the interest is going to be that amount minus how much I put in originally. That's the 100,000. And so the interest, 100,000. So the interest is just going to be, if it's compound interest, it's just going to be that difference, 58,687.43, where if it were simple interest, I would have earned 48,000. So considerably more, okay, just because it was compound interest. All right, now here's another one that's from 7.4, compound interest. So the principal, 3,000. Interest rate, 0.115. Quarterly means n equals 4. And then we're going to raise it to the 4 times the 5.5. Multiply those two. It's good to multiply those two out. Okay, so I'm going to take the 5.5 times 4 and get 22, regardless of what kind of calculator you have. It works good to have worked that out. Now, on my calculator, I don't have that multi-view. I can just do this, and it will do the right thing. Close the parenthesis, raise it to the 22nd power, and that'll give me my answer. So that's the setup on that one. But 17 is a little bit harder, because what we want to know there is what would we have to invest today? So we want to know the P so that we'd have 25,000 in the future, 18 years from now, and we know it's 9% compounded monthly. So we're going to use this, but we don't know the P, okay? But we do know our interest rate is 9%, compounded monthly, so it's N is 12, and then it's going to stay there for 18 years. And we want it to turn out to be 25,000. So that's the A, the future value. So you're going to need to take your P and take that 25,000 and divide it by that 1 plus 0.09 over 12, okay, raised to whatever 12 times 18 is. I think it's 216. 12 times 18 to the 216 power, okay? And you can try that to double check your answer looking at the answer sheet. All right, and then one more, effective rate formula. That's going to be on the formula sheet. For that one, you take this formula and you just plug in, and that'll convert the nominal rate of 17%. It's compounded semi-annually. It will tell you what the equivalent simple interest rate would have been. So you do this really to try to compare different investments where they have different compounding periods. So we're just doing the one, so we're just going to be plugging in the 17% change to a decimal, dividing by, compounded semi-annually means n equals 2, dividing by 2, raising it to the second power and subtracting 1. So you just work that out, and it'll turn out to be a decimal. So let's do that. Okay, and I'm raising it to the second power, subtracting 1, and I get 0.177225. It's always going to be in the ballpark of this stated rate, but it'll usually be just a little bit higher. So when you change it to a percent, move it twice, and then they might say round to the nearest tenth or hundredth, but I'm gonna round to the nearest hundredth. 17.72%. Okay, so it was a stated rate of 17%, but because they calculate the interest and put it in your account where you'll earn interest on that, it actually turns out to be 17.72% when you're finished.